So with this in mind, now we are coming back to talk about the moment of a force about a given axis. That's the second kind of moment. Okay? So what is the second kind of moment? The second kind of moment, in fact, is the projection of this force vector on this given axis, in fact. Okay? However, we need to first calculate the moment, which is the first kind of moment. What you need to do, you just pick any point along this given axis. Any point along this given axis. If this given axis passing through point O, which is the original point, then just why not to take this original point? But obviously, you can take any point you like. Okay, that doesn't matter. So first of all, you need to calculate the first type of moment, which is the moment of this force about this point you just picked. And that point can be any point in this given axis. Let's say point O. So then you need to first calculate the moment of this force about this point O. That's the first kind of moment. That is R cross F. R is the distance vector from O to point A, which is the point the force applied on. So that's R. And then cross F. So this is the first kind of moment. Once you get the first kind of moment, then you take the projection of this first kind of moment on this given axis, which means you need to multiply with lambda. So whether you want to use this moment dot lambda or lambda dot this doesn't matter, because the scalar product A dot B equal to B dot A doesn't matter. So if you want to write this moment dot lambda or you want lambda dot moment, that's the same thing. But this is the definition of the second type of moment, which is called the moment of a force about a given axis. What you need to do is to find out the lambda with a unit vector along this given axis. When we give you the given axis, of course, it's very easy to calculate the unit vector for that given axis. And then you need to calculate the moment of a force about a point, any point in this given axis, on this given axis. Okay? So in reality, I'm going to show you this given axis may not pass through this point O. You can do the same thing. Okay? Before I reach this slide, I just want to tell you the moment by definition is this. So this time, what you need to do is to do the cross product first, just like the previous ones. We calculate the moment of a force about a given point. After we get this one, don't forget, you need to dot with this lambda. And this is the definition of the second type of moment of a force about a given axis. And then you may say, well, this given axis has to pass through this point O, original point. No. Any given axis is okay. So now, let's make it even more general. There is a force acting on point A, assuming the rigid body is large enough. Assuming the rigid body is large enough, right? So point A, point B, point C, any points, they are inside the rigid body, or on the surface. So what is the moment of this force about this given point, about this given axis? It's called L. So what is the moment of this force about this given axis? So what you need to do is to first randomly pick up a point on this given axis. You say, well, I can choose many points. Yeah, any point you want. The final answer is the same if you do it correctly. So for example, you want to choose point C. No problem. You want to choose point C, then what you need to do is to follow the definition lambda dot R cross F, right? So first of all, you need to identify lambda, which means lambda is a unit vector of this straight line, assuming we know lambda. And then we need to dot with the moment of this force about point C. Of course, this equation is to pick another point B. Point C, same thing. This second kind of moment of this force about this given axis L, whether it's you pick point B, point C, the same final answer, same thing. So you calculate the moment of this force about point C. That means from C to A. That's the distance vector, and then cross F. And then you dot with lambda, and that is the second kind of moment. But for whatever reason, you say, well, I don't like point C. I want to choose point B. Is that a problem? No problem. Okay. In the middle process, the numbers are different, but the final answer should be the same. By choosing point B, then what is the second type of moment of this force about this given axis? Again, you first need to find out the lambda, which is a unit vector in this line. That's pretty easy to find, as long as you find 2 points. and then dot with the moment of this force about point B. That means from B to A, that's the distance vector. That's the distance vector. So A minus B, and then cross this force F. So the final result is independent. So here's the statement, right? The final result is independent of the point B along the given axis. In other words, if you don't choose point B, you choose point C, the final result is the same, because the final result is independent of the point you chose. Okay? So that is, the same result can be obtained by using R C to A if you choose point C, for example. So that's the same. So this is the definition for three-dimensional moment of a force about a given axis. Okay? And further, I want to make a comment. The final result of the second kind of moment is a scalar. The reason scalar is because finally you are dealing with a vector dot with another vector, and the final result is a scalar. So the second kind of moment is a projection of the first kind of moment. It's a special case. But you don't need to worry about the direction. The direction is, there's no direction because there's a scalar. Okay? So what I'm going to do is to talk about this a typical example just to show you how we are going to calculate the second kind of moment. Okay? But there's a typical three-dimensional object with forces applied on. So let's take a look about this example. A cube is acted on by a force P. So this is a force P. This is a cube. A, B, C, D, E, F, G. Probably this is a point H, I guess. So there's a force acting on point F. So we need to calculate three things, right? Calculate the moment of this force P about point A. So then this is the first type of moment, right? Also, we need to calculate the moment of this P about this given axis, AB, or it's called edge AB. Where is AB? This one. So the second question asks us to calculate the moment of this force P with this given axis, AB. The third question is to let us calculate the moment of this P about another given axis. It's called AG here. Okay? Well, that's fine. We just do step by step. So let's do the first one, which is the first type of moment, right? What is the moment of this P about a given point A? Where's the given point A? Here's the point A, right? Okay, so let's do it. The moment of this force P about point A, which is the first type of moment from previous formulation we can see, which is R cross P, right? So it's R cross P. That's the moment at point A. Here, the point A. The difference between this picture and the previous one is this time we need to establish the three-dimensional Cartesian coordinate system. Always the case. Otherwise, how are we going to calculate the components, right? So, but it's really up to us how we are going to establish the Cartesian coordinate system. Okay. So, for example, if you want to choose this is x, this is the y, this is z, then correspondingly you have I, j, k, which are the unit vectors along these three axes. Now, what is the moment of this force about point A? That is R cross P. So let's first figure out R. What is R? R is the distance vector from the point you want to calculate the moment of to the point the force is applied on, right? So that's point F. So in other words, this R is from A to F. From A to F. That is called R, distance vector, to be used here. So then what you need to do is to find the three components of this one and find the three components of this one, and then you do the subtraction. So what are the three components of point F? The three components of point F, that is A, 0, A, right? So A, 0, A. These are the three components. A, 0, A. What are the three components of point A? There's no x component. That's 0, A, A. So 0, A, A. So A, 0, A, subtract 0, A, A. So then the first one, this is A subtract 0. That's still A. That's why you have this one here. And then y component, there's this one has no y components. But this one has y components, which is A. So 0 minus A, that's equal to negative AJ. The third component, that is A, And the third component of this one is also A, so A minus is 0. That's why you don't have something with K. So this is R, right? So using F subtract A, this is what you finally end up with. That should be simple enough. Second, what is a force P vector which is applied on point F? This force vector P equal to the magnitude of this P. Let's just use this symbol P, but this and this are different because this is the magnitude. That means without the arrow on top. This is the vector, you put the arrow on top. So that's going to be P times lambda. And lambda is a unit vector of this force line. So how to calculate the unit vector of this force line? Well, that's also easy from our previous chapter. In order to calculate unit vector in force line, then all we need to do is to find 2 points, right? So find 2 points in this force line. So obviously, the example gave us 2 points. So why not to take advantage of those 2 points, point C and point F. So we use a C, point C, subtract point F, and don't forget to divide it by the length between C and F, which is the norm. So then, finally, this is lambda. Use C, subtract F, and divide it by the distance between C and F. And this is what you'll finally get. And by the way, this is the P divided by 2 square root. That's it. These are not in the denominator, okay? So the textbook didn't give us a very clear writing. So P over this together is just one term. And then multiply with this one. In other words, J and K are in the numerator, not the denominator, okay? So if you really do not want to be confused, put another parenthesis here so that you know J and K are in the numerator, not the denominator. Yeah, this is good. This is good. So that's clearly indicate this in the numerator, right? Okay, so we got P, we got R. Now we just need to do the math, okay? So using R cross P. So R cross P. So then basically you just need to know I cross J. I cross J equal to K. That's going to be a K term. And I cross K equal to negative J, another term. And J cross J equal to 0. They don't need to worry about that. And J cross K equal to I. So finally you have this one in term of IJK. No matter what, this first type of moment is always a vector with whatever component you can calculate. So that's the first question, right? Asking us to calculate the moment of this force about this point A. Any questions? Okay, so if you have no questions, let's move to the second. Determine the moment of this P about the given axis, or called edge AB. Where is the edge AB? This is edge AB, right? Okay, so obviously this is the moment of a force about a given axis. That's a second type of moment, which is the projection. Okay. The moment of this force P about the given axis AB, by definition, is a lambda dot with this R cross F. Okay, so you can randomly pick any point you like along this given axis AB. So this is the given axis AB, and this is the force, right? So what is the moment of this force about this given axis AB? Remember? Not this one. Where? I missed one slide. Okay. This one, right? So what is the moment of this force about this given axis? Well, this is the equation. But before you pick this equation, you need to pick a point on that given axis. So whether you choose point B, choose point C, doesn't matter. Okay? So back to this one. We need to pick a point. What is the moment of this P about this given axis? Well, we need to pick a point on this given axis. Well, at least the example already gave us 2 points, right? You can pick point A or you can pick point B. It's really up to you. Okay? So let's say we pick point A. If we pick point A, then what you need to do is lambda with a unit vector in this given axis dot with R cross F. But at point A, in other words, you can write the moment at point A given by this force. Okay? So first of all, let's determine lambda, which is the unit vector in this force in this given axis AB. This given axis AB, in fact, is what? That's a parallel to x-axis. So then obviously this unit vector is the same with this I. If you do not like to take advantage of this conclusion, you basically pick up 2 points, you can calculate the unit vector, it's not a problem. You finally end up with I. Okay, so then instead of writing lambda, I'm going to write I, because that's a unit vector of given axis AB. And then multiply with R cross F. So R is the distance vector from the point you pick A to the another point, the force applied on, that's from A to F, and then cross F. And then actually, you know what? This is exactly this. So that's why R cross F is the moment at the point A you pick. So then why not to take advantage of the solution you already got from step number 1 and plug into here. So this is exactly what we have here, which is the moment of this force about any point you pick, at point A, in this given axis, which is here, and then dot with I. So then it's very easy, right? I dot j equal to 0, I dot k equal to 0, only I dot I equal to 1. So then this is the final answer, which is right here. AP divided by 2 square root. Okay, so because of dot product, I dot I equal to self, I dot j equals 0, I dot k equals 0. Okay, so this is the moment, or it's called the projection of the force P about, the moment of P about this given axis AB. I have one comment to say. You may say, well, the unit vector of this given axis AB, I don't believe that is I. I think that is a negative I, because I'm thinking this given axis is from B to A. So instead of using I, can I use a negative I? And the answer is yes. This is the only exception for what we call the given axis. Because normally we say there's a given axis. There's a given axis, right? So normally we do not define that given axis is from C to B or from B to C. Normally we do not define it. It's up to you to define. So then you can say the lambda is going that direction or the lambda is going down. That's the same. It's not a problem. It's going to affect your final answer just a little bit. So for example, if you do not choose the unit vector AB, which is I, you choose a negative I, that's fine. Your final answer is a negative AP divided by 2 square root. That's also treated as the same answer. Okay, because that's a projection. Okay, whether you want to put additional negative sign or not, doesn't matter. The bottom line is, this is the answer. Okay, so that's the second question, which is the moment of this force about this given axis AB. So with this, then we can easily deal with the third one. Okay, so what is the moment of this force P about another given axis with a diagonal AG? This one is no longer AB, AG. Same thing. So if we follow the definition, right? The moment of force P about the given axis AG should be equal to lambda dot R cross F. And before you want to calculate this R cross F, that's this term, which is called M or whatever, you need to pick a point on this given axis AG. So this given axis AG, at least you can easily see 2 points, right? You can see point A, you can see point G. So it's really up to you which point you want to take. For example, you want to take point A, and then you do the math, you finally get the answer. Or you say, oh, I don't like to choose point A, I want to choose point G. Is there any problem? It's not a problem. In the middle process, it can be different. The final answer must be the same. Okay, so then it's really up to you which point you want to choose. You can say, oh, I don't like A, I don't like G either. Can I choose somewhere in between this point? I can create a point. Not a problem. As long as you do it correctly, your final answer should be the same. So back to this one, I'm going to choose point A, because I can again take advantage from the solution we got from the previous one. Okay, so let's say I pick point A. Then the problem becomes, what is the moment of this force about this given axis AG by picking point A? So again, that's going to be lambda with a unit vector of AG dot with R cross F. But this time, this R is the point you pick to the point the force applied. So again, that's from A to F and then cross F. So A, the distance vector from A to F, that's the R cross F, cross P, that's exactly this, right? So then I'm basically copying this one to here directly. So MA, again, is this one. So AP divided by 2 square root IJK, which is, of course, the same with this, right? So basically, we're done with the second term. We just need to go back to look at the first term, which is called the lambda. In other words, that's a unit vector. So what is a unit vector of this given axis AG. If we need to calculate unit vector of this given axis, all we need to do is to pick 2 points, right? So what are the 2 points you want to pick? Well, there are 2 points already there, so why not just to take advantage of those existing 2 points? That's called point A and point G. Okay, and then we're going to say G subtract A. For this given axis, again, there's no direction, in fact. If you say, oh, I don't know why it is from A to G, can I say from G to A? It's not a problem, okay, for this, because there's no real direction. So then, either you want to use this as a start point to another point G, that means G subtract A, or use A subtract G, that's the same. So let's say this is the start point, this is the end point, that's going to be G subtract A. So G subtract A is the distance vector, but don't forget to divide it by distance between A and G. Don't forget to divide it by distance between A and G, right? So first of all, what are the 3 components of point G? The 3 components of point G is A, 0, 0, because this is in this x-axis. So A, 0, 0. What are the 3 components of point A? The 3 components of point A is a 0, A, A, right? So that's a 0, 0, that is a 0, A, A. So A, 0, 0 subtract 0, A, A, that's going to be A, negative A, and the negative A. Okay, so you do the simple math, you can get the numerator, that is the distance vector from A to G using 3 component point G, subtract 3 component point A, that's what you got. But don't forget divided by the distance from A to G, that means square root A squared plus A squared plus A squared. Then finally you have A and 3 square root. So A will be cancelled. This is what you'll finally get to be the lambda. You have questions?
I think that's G minus A though, right?
Yeah, it's G minus A, right. Yeah. But what I'm saying is, with a given axis, you can use A subtract G. It's not a problem either. So finally, and if you use A subtract G, you'll finally end up with this negative I, positive J, positive K. That's the same. Any other questions? Okay, so we now got the lambda. So what we need to do next, to plug in this lambda back into here and then dot with this solution. So finally, we end up with this, which is lambda 1 over 3 square root I minus J minus K. That's the first vector lambda, dot with the second vector, which is AP over 2 square root I, J, K. And you do the math, this is what you finally end up with. Okay, so this cancels out. Then you have AP divided by 6 square root. That's a negative sign. That's a positive sign. So whether the projection is positive, which is here, or negative, which is here, it doesn't matter. Okay, so we are basically looking at this number. So if you choose G as a start point and then A is the end point, then actually you finally end up with a positive AP divided by 6 square root. So the bottom line is we don't care whether it's a positive or negative. So in other words, you pick which is the start point, which is the end point, with what we call the given axis. But this is the only exception. So when we talk about force vector, when we talk about force direction, you have to make sure you establish the correct start and end points. Okay, so this example typically show you how we can calculate the second type of moment, which is the moment of a force about any given axis. The bottom line is, you just need to randomly pick a point and then you follow this equation. So this is a single equation, however, you need to do the math twice. One is do the cross product and then you do the dot product. So that's why you have to do both. Okay? This is the second kind of moment.